Assalamualaikum warahmatullahi wabarakatuh. So basically, we are from Group 8. We present about a project-oriented problem-based learning, POPBL. So this is our member, our team, Hisham Rabisham bin Amazlan, Fahran Najmi bin Kamaruddin, Muhammad Shahrul Razi bin Amiruddin, and Khalid Saifullah bin Ibrahim. So introduction. This project oriented based learning POBL focus on analyzing and understanding four popular scheduling algorithm. First one is the first come first serve FCFS, and number two is the shortest job first SJF, and number three is a round bin RR, and number four is the priority scheduling. So by implementing and simulating this algorithm, student will gain practical insight into their strengths and limitation, and perform metrics such as waiting and time and CPU utilization. So these projects aim to enhance problem skill and critical thinking ability and knowledge in the scheduling algorithm, analyze for computer science student and professional. So we go to the problem statement. So in the problem statement, actually we are study about the result of complete over resources, reduce speed of operation, and efficient use resource in impacts several areas including environment with the multiple user, task heavily in utilize CPU and real-time system, process relying on input-output operation and server setup, distributed computing scenario with the power limited device and real-time multimedia application. So the aim is to tackle this issue through the examination and implementation of the variable scheduling algorithm. So we go to the objective. The objective of this project is to involve becoming acquainted with the concept and vocabulary related with process scheduling in an operation system. So next is the intent examining and comprehensive different scheduling algorithm. So that I mentioned before, we have the first come first serve, shortest job first, round bin, and priority scheduling. So through simulation, the performance of each algorithm will be analyzed and compare. And last one is the project aims to discuss fairness and efficiency of each algorithm and prioritizing processes. So we get next to the project description. So this project is the content of 4 member will research the process scheduling concept terminology by follow the blending first come first serve, serve job first, round bin, and priority scheduling algorithm in the C language and C++ language. So simulation will be conducted by analyzing performance with metrics including turnaround time and waiting time. And the visual representation about the Gantt chart will be compared with simulation result, and the team will evaluate strength and weakness, fairness and effectiveness of each algorithm. So thank you.
Today, I will present to you number 5 scheduling algorithm analysis. The analysis of scheduling algorithm encompasses for fundamental algorithm first come first serve CFS, shortest job first SJF, round robin RR, and priority scheduling. Each algorithm possesses distinct characteristics and influences the scheduling and execution of processes in its own way. Though through in-depth examination and analysis of this algorithm, valuable insight can be gained regarding their performance, advantages, and limitation across various scenarios. The analysis process entails assessing metrics like waiting time, turnaround time, CPU utilization, and fairness to effectively compare and contrast the efficiency of each algorithm. So I will present to you 5.1, which is first come first serve FCFS algorithm description. The first come first serve scheduling algorithm serves processes in the order they arrive. It has low overhead but can result in increases waiting time and the convey effect. When long-running processes delay subsequent one, it is suitable for scenarios prioritizing fairness and simple implementation. So this is the program code for the first come first serve, and then the left side is the result from the simulation. The process, there are three process, which is process 1, process 2, and process 3. And then the burst time for the first one is 24, the second one 3, and the third one is 3. And then after run the coding, we will get the result, which is the burst time, waiting time, and turnaround time. We can see in the table at the right, there are the result. Burst time for the process ID 1 is 24, the waiting time is 0, turnaround is time is 24. Process ID 2, burst time is 3, waiting time 24, turnaround time 37, and process ID for the 3, the third one. Burst time is 3, waiting time is 27, and the turnaround time is 30. Analysis. The simulation results include the waiting time and turnaround time for each process, along with their average values. Waiting time represents the duration the process spends in the ready queue, while turnaround time reflects the total time from process arrive to completion. In the given result, the initial process period is a bit waiting time of 0 since it arrived first. Subsequent process experience increase waiting time as they must wait for earlier process to finish execution. Comparison with theoretical analysis. In the theoretical analysis of the first come first serve SFS algorithm, the waiting time for a process is dependent on the arrival time and burst time of preceding processes. Longer burst time of preceding processes result in increased waiting time. Comparing the simulation result with the theoretical analysis, we can observe that the simulation align with the expected behavior of the FFS algorithm. Processes with shorter burst time, such as PID5, have relatively shorter waiting time, while processes with longer burst times like PID1 experience longer waiting time. The average waiting time and average turnaround time obtained from the simulation results provide insight into the overall performance of the FSS algorithm. In the specific scenario, the average waiting time is approximately 17.000000, and the average turnaround this time is approximately 127.000000. This values represent the average waiting time turnaround times experienced by the process in the given scenario. Overall, the FCFS algorithm performed adequately when the burst time of process are relatively balanced. However, it might not be suitable for scenarios where there is a mix of short and long burst time, as it can lead to increased waiting time for longer process and potential delays for subsequent processes. So this is a for simulation result, which is 70.000. Average turnaround times 127.000. And then the right side, the picture one is the theoretical result that has been calculated. They have Gantt chart, waiting time, average waiting time, turnaround time, and the average turnaround time. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafir Razi Amiruddin. We have a number metric of CN to 000105. So right now I'm going to present about shortest job first, SJF. So the description of SJF, it prioritize processes based on their burst time, selecting the process with the shortest burst time for execution first. aims to minimize total execution time and waiting time. So SJF can lead to reduce waiting times and turnaround times, but it requires accurate knowledge of burst time in advance, which can be challenging in real-world scenarios. So this is the program code of SGF that we use to get the waiting time and turnaround time. So these are our simulation result and analysis. So on the left here is our uh, execute executed program code, and to the right is the table of process which we use for process. On the burst time is 1447, waiting time is 0159, turnaround time 15916. So the average that we so the average waiting time calculated as 3.75, and the average of turnaround time is 7.75. So in the simulation, the waiting time represents the duration process spans in the ready queue before it starts execution. The process with shorter burst time are scheduled first, resulting in lower waiting time. The process with the shortest burst time P3 has a waiting time of 0, while the process of the longest burst time P1 has a time of 9, which is the uh, short time. So turnaround time indicate the total time taken by a process from arrival to completion, including both waiting time and execution time. Process with shorter burst time have lower turnaround time. The SJF schedule algorithm prioritize process with shorter burst time, aiming yeah. So that's it for SJF, and this is the comparison with theoretical analysis. Uh, so this is the comparison from the uh, result that we get from the coding, and we uh, calculate using the theory that we get. So the comparison is really the same. The simulation result is 3, average waiting time is 3.75, average turnaround time 7.75, and the theoretical results, which is the same. Average waiting time is 3.75 and average turnaround time is 7.75. So the comparison with theoretical analysis, the simulation results achieved with the SJF scheduling algorithm align precisely with the theoretical analysis. The average waiting time and an average turnaround time obtained from the simulation match the theoretical value precisely. Next, we go to round robin (RR). Round robin is a preemptive scheduling algorithm that decides CPU time into fixed time slices. Each process is allocated a time slice, and the CPU is switched between processes once the time quantum expires. RR round robin ensures fair allocation of CPU time, prevent process starvation, and provides responsiveness. So the choice of an appropriate time quantum is important to balance system overhead and process responsiveness. Robin is effective in scenario prioritizing fairness and balanced CPU utilization. So this is the coding that we use for our round robin. Next is the result and analysis. The left side is the program that we get, and the right side is the table of round robin for arrival time, burst time, waiting time, and turnaround time. So for the process, the total process that we use for round robin is 3. So P1, P2, and P3. The round robin algorithm ensures that each process gets a fair share of the CPU time by executing them in a secular manner with a fixed time quantum. The algorithm avoids process starvation. Next, comparison with theoretical. So, uh, comparison for the simulation result, we get average waiting time is 5.66667. Average time turnaround time is 15.6667. And the theoretical results that we calculated manually is average waiting time is 5.66 millisecond. Average turnaround time is 15.667 millisecond. So comparison with theoretical analysis, round robin scheduling algorithm align precisely with the theoretical analysis. The average waiting time and average turnaround time obtained from the simulation match the theoretical value exactly. The consistent confirm that the simulation effectively captures the behavior of the RR algorithm, validating the accuracy of the calculation and the correctness of the simulation. Next, we go to priority scheduling. Priority scheduling algorithm where process are assigned priorities and the CPU is allocated to the process with the highest priority. Processor can have static or dynamic priorities based on factors like importance or resource requirement. Priority scheduling improves response time and resource allocation but require careful priority assignment to avoid starvation. It can be implemented as preemptive or non-preemptive. The algorithm selects the highest priority process from a priority queue for execution. Priority scheduling enable effective process management based on priority, but priority assignment and starvation prevention must be considered. So this is our program for priority scheduling that we use to execute. This is the simulation and result analysis. Uh, so we use five process, which is P1, P2, P3, and P3, P4, and P5. And the priority of P1 is 3, P2 priority P2 is 1, priority P3 is 4, priority P4 is 5, and lastly priority P5 is 2. And the burst time for P1 is 10, P2 is 1, P3 is 2, P4 is 1, and lastly burst time for P5 is 5. Next, comparison with theoretical analysis for priority scheduling. Simulation uh, simulation result that we get from priority scheduling for average waiting time is 8.2 and average turnaround time is 12. So for the theoretical results that we calculate, average waiting time we get 8.2 millisecond and average turnaround time is 12 milliseconds. Comparison with theoretical analysis for priority scheduling, the simulation result match the theory result for both average turnaround time and average waiting time. The simulation confirmed that the average turnaround time is 12 units and the average waiting time is 8.2 units, which aligns with the theoretical calculations. So that's all for me. Thank you very much.
Hi, my name is Sham Abisham, and I'm going to present about 5.5, which is Summary of Scheduling Algorithm. So, in the project, we conducted a comprehensive study on scheduling algorithm and operating systems. We examined four algorithms, which is first come, first serve, FCFS, shortest job first, SJF, round robin, RR, and priority scheduling. FCFS is simple but can have high waiting times for long processes. SGF minimize waiting time but require prior knowledge of burst times. RR ensures fair CPU time allocation but can be inefficient for long processes. Priority scheduling allows prioritization but can lead to starvation of lower priority processes. Simulation and visual representation like Gantt charts help compare the algorithm performance. The finding that the selection of the most suitable algorithm based on specific requirements, considering metrics such as turnaround time and waiting time. And moving on to the conclusion, the study of process scheduling algorithm in operating system provides valuable insight into the impact on system efficiency. Algorithms like FCFS, SGF, RR, and prior scheduling were evaluated based on metrics such as turnaround time, waiting time, and fairness. FCFS is easy to understand but can result in higher waiting time for longer processes. SGF minimizes waiting time but requires prior knowledge of burst times. RR provides fair CPU time allocation but introduces overhead for longer processes. Priority scheduling prioritizes tasks based on levels but require careful management to avoid starvation. Simulation and visual tools aid in analyzing algorithm performance. The choice of a scheduling algorithm depends on system requirements and process characteristics, with the findings serving as a foundation for further research and optimization to improve system performance and efficiency in diverse operating system environments. So that's all from us. Thank you so much.